안녕하세요. 저는 마코토입니다. 여러분 만나서 반갑습니다. This is my third year, I think, presenting at BUIDL Asia ETH Seoul, and every year before my talk, my lovely Korean wife says you ensure to greet people in Korean. So I just finished that part, so I feel very relieved. So rest is whatever. But anyway, yeah. So this is our year, and every year, if you have seen my talk before, I'm known as doodling some cute pop NFT. So if you are interested in collecting pop, come to see me. So you can tap and collect the NFT to say you met me, and also listen to my talk. And today, my talk is about cross-chain communication for app chains and ENS as a use case. And earlier in the talk, Charles' talk from Espresso, he asked how many people has built L2, and it was only, I think, Zach from Aztec. But I think I'm actually the kind of second people in that room that building the layer 2, and hopefully in next few years, I think more people are going to make it. So this is kind of lesson learning as we are building the chain. And yeah, just in case you don't know what ENS Ethereum name is, Ethereum name service provides this hexadecimal Ethereum or other crypto addresses to easy to read human readable names such as Makoto.eth. So if you go to wallets such as MetaMask, and if you look up Makoto.eth, you know where to send ETH. And so we've been running since 2017, and it's one of the oldest dApps or Ethereum-based applications. We have over 1.9 million names owned by 100 unique addresses, and also we have over 14 million so-called off-chain names such as Uni and Base. And what that means is that we develop a protocol called EIP3668, also known as CCIP read, which allows you to basically by default you store the in our example, there's a name and there's an address. The address information is usually stored in layer 1. But because it's going to be expensive, sometimes when gas is expensive, it's going to be prohibitive to use a service. Hence, we developed the ways to be able to set the record anywhere outside of layer 1. So it could be your normal database, or it could be your layer 2 or sidechain. And by using that, that protocol itself has been there for almost 4 years. So for my last 2 years talk is all about explaining how exactly that works. So I'm not going to repeat this here, but by using that, there's already a company like Base issued base.is on their base chain, and also I think Uniswap, one of the most popular DEX, has issued subnames if they install, and you can get the Uni subname if you install their wallet, and also Linear as well. So this is kind of our cross-chain kind of strategy we've been developing in-house. But now we are getting to the time that the idea of the mechanism CCIP read is if you set the storage into off-chain, all the subnames you issue belongs to that specific off-chain. And so by using the same logic, if you actually move .is registry, you can add to the brand new chain. Actually, that becomes layer 2, and you can just we are going to issue all the basically secondary names into our specific chain called we decided to call it name chain. And so today, so this is about me kind of sharing the experience of building the name chain. And so we kind of going to dissect different aspects of the requirement, and just talk us through the challenges and what kind of options are available and what kind of consideration you have to make. So hopefully when you make your own app chain or in future, you can also kind of think in a similar way. And as I keep repeating, we are still building ENS chain, and so if I get invited next year, I might by that time hopefully I have we have a name chain launch, and I might be giving like the different stuff like what we thought is going to work, but it might not be the case. And so first, we'd like to dissect name chain as a app chain with a different aspect. So we trying to be name chain is we're trying to be the chain for the identity, and not just for .eth users, but for all these chains across different Ethereum ecosystem. And when we first built the architecture back in 2017, there was no layer 2. So we didn't really cater our architecture for that purpose. So we had a kind of monoholic registry contract in layer 1, but we are actually rewriting from scratch to make it hierarchically, and you can move the part of the registry to different chains as you wish. And so that's a big chain we are rewriting right now. And also important thing is most of the, I think, the L2 chains, they're trying to kind of bring the liquidity or like an asset to be, and they use, if you look into the L2B or something, you see lots of chain, and the only one matrix is like how much money is in this chain, but that's not really our priority. Our priority is to be able to issue registered names in affordable manner, and yeah, we don't necessarily expect lots of like a DEX or like staking protocol or lending protocol to be in the chain, which might introduce different issues. And also, if I dissect what kind of operation will involve especially in the area of cross-chain, I usually I kind of analyze into three. And the first one is registration and renewal, which is about basically when you register ENS names, it usually costs about $5 a year, and you have to basically pay in $5 worth in ETH. And however, like so most of the, I think, in cross-chain operation is very low value, but that happens frequently. We have over 1,000 registration a year, so we expect there's lots of small amount of bridge crossing every day. But at the same time, when the name expires, it goes into a so-called Dutch auction, where price starts from 100 million and it goes over to zero over 21 days. And the idea is that like quite often in a traditional kind of domain world, whenever a name expires, like bots or like professional people just try to snatch it, so like normal people are unable to obtain the newly available names. To prevent that, we provide an auction system, but that brings new challenges, especially for the cross-chain world. And also, ENS is known for one of the NFT project, non-fungible token, and so like name is unique. So crossing a name, non-fungible asset cross-chain brings different problems. And so what kind of challenges it brings is that, first of all, if I don't know how many of you have used cross-chain bridges experience, but like if I try to build the Ethereum name registration process in a naive way, I can see at least like 7 different steps. Like first, you switch network to layer 2, any of the layer 2 you might be in, like you might be using Base or you might be using Optimism. Then you bridge the asset to name chain, and you have to wait until the asset is crossed. And then we also do actually require 2 transactions to prevent the front running. That like in the DEX world, I think front running is a big problem. Like people try to, as soon as your order is in, people see their value and they try to front run you to get a better deal. To prevent that, in our case, we use so-called commit and reveal logic. That's been placed since, I think, 2020. That when you commit, you just put the hash of your name, secret, and the owner information. And when you reveal, you put the actual names. But if someone tries to front run the reveal information, they actually have to go through the commit and wait process. So like that prevents you to do things cross-chain. But to prevent the to front-run the name. But doing that again in a cross-chain and causes a bit of issue. And the idea is we try to make it as smooth as possible. And I already explained about the temporary premium for the Dutch auction. And yeah, modifications I'll just go through. And so optional consideration, ideally, unlike the one I showed with the 7-8 different steps, it should be just 1 or 2 steps. This is where we want to strive. And we also expect that because we don't have daily kind of DEX activity, we don't expect people to be in our chain when people start their registration. We expect that always a user are in their favorite chain, but we let you to register with a name as fewer steps as possible. This is, and so some of the options you usually have. Most blockchain layer 2 chain has something called canonical bridge, which comes with the roll-up steps, and they are kind of more secure way, but it's actually a lot slower. So most DeFi uses, people often use so-called relay, such as Across or Relay, and the basic idea is that they basically front, once you try to bridge the asset, they basically have the already liquidity in both sides of the chain, and they basically kind of lend you the asset in 10 seconds. And after like hours, probably minutes or hours, when the canonical bridge actually bridge the asset, they take the money back. And this is more popular way, and it allows you to bridge asset in like 10 seconds or a few minutes. But that has some limitation that basically the amount you can send is down to the liquidity each relayer have. And also there's some security risk which canonical bridge doesn't have. Security of the canonical bridge is like as strong as the roll-up system itself, whereas they have their own kind of relaying mechanism which could be compromised. And if you dissect that to, map it to our needs, you can say like you can use relayer for like a registration and renew purpose, which is like, it happens frequently and a low amount, but you can't really use it for the Dutch auction temporary premium or the NFT bridging. So like, and also even for the canonical bridge, I think Uma from Succinct explained that optimistic roll-up takes like up to 7 days for the bridging process from L2 to L1. That is almost like unusable from UI. So from the chain selection wise, we took this part as a chain selection criteria, and we decided to partner with Linear as a layer 2. So like a Linear has a ZK roll-up, which provides a faster finality, so that the NFT bridging cost takes a lot less time than the fraud-proof alternatives. And also, I actually added this slide while I was listening to Charles' talk earlier, that basically he advocated for the pre-confirmation. And actually, when we are having the cross-chain conversation, you often get brought, like, can you not use fast confirmation? And I think fast confirmation is a great approach for many use cases. But if you think about our approach is that this, when I first explained the EIP 3668 CCIP read, that actually is a technology to kind of enable cross-chain data reading by verifying in the state root of L2 on L1. And to make it happen, actually the L2 data has to be settled in L1 to make it work. So because pre-confirmation isn't necessarily the settlement, it doesn't necessarily work for name change. So for that reason, like, it does work for most use cases, but if you think about your use case, our use cases, it doesn't work. And yes, then so once you bridge the asset, you have a commit and reveal operation, which is like 2 operations, and we want to minimize, bridge, commit, and reveal, which is 3 steps, which we want to minimize. And we look into account abstraction, especially the ERC 437, which enables a batch operation and gas sponsorship. This is good, and also we are aware that there's an upcoming Ethereum hardware called Pectra, which comes with ERC 7702, which turns all the EOA as SCA. So these one sounds like allows solve all the problem. But again, if you look into the individual use cases, something like commit and reveal model cannot be batched, because if you like have the reveal information with commit, whoever intercept the transaction can basically overrun it. And for the 7702, even if 77, and that's one problem. And even after, for the second problem, you also have to have 2, I think, how to explain? As an app, there's many, you have to cater for many different use cases and many different wallets. And every wallet try to provide their own best use cases, but to make it consistent for all the wallets, 7702 is a bit difficult option, because 7702, each wallet decides a smart account to use. So we don't know what kind of smart account implementation is in place. So this, again, it doesn't necessarily solve our problem out of the box. So what we are thinking right now is, for the first problem of you cannot combine commit and reveal, we are also looking into another specification called smart session, which basically app can ask EOA to grant permission to someone else. So once it's done, you have to create one confirmation, but after that, all other transactions you can invoke. Once it's like kind of approved, you can invoke this transaction without lots of clicks. So, and there's a few implementation presented, one for Rhinestone, another for the MetaMask Delegator. So for using these, you should be able to minimize the number of transactions. And for also the kind of lack of consistent ways to provide experience for the smart account, we are currently thinking about not just relying on the wallet prepared smart account, but when people first bridge the asset, we basically create a smart account on name chain and mint the name chain to the smart account and add the end user as a signer, so that like we can provide a consistent smart account experience. And also by doing that, smart account comes, if you use EOA 7702 as a smart account, it provides a kind of a batching and gas sponsoring feature, but it doesn't add any security. Whereas if you actually use smart account to own the contract, it can add up lots of security options. But there's some downside that, like, if you register a name thinking I'm gonna own, but some randomly created a smart account, ownership is transferred to the randomly created smart account, that's gonna cause some like a discoverability problem, so which we have to solve as well. So I quickly went through all these kind of nitty-gritty detail of like what you have to think about when you actually create a custom-made chain for your own needs. And as I mentioned, like, there's no one-size-fits-all solution, so you have to kind of look into each of the components of your requirement and solution, and you have to mix and match to suit your needs. That's it. Thank you.